Welcome everyone to today's Mbed OS Tech Forum. This is actually our first episode. Hi Don, welcome.
Hi Alessandro, thanks. Very cool intro. I'm excited. And we have a lot to talk about today.
Absolutely. I mean, it's going to be a really feature-packed episode, and I'm looking forward to all the different aspects. I think it might be useful actually to give a bit of an overview of what we'll be speaking about today. So we'll have actually some guests from our community and our developers, working out in the field on many different things. Actually, these guys are working on rockets, so we'll have them first telling us their story and how they've been using Mbed OS. We'll then look at some current features that we're working on Mbed OS, and then we'll end on actually talking about future features and really cool stuff that we've got in the pipeline. So, I think, if you've got any questions or anything that you want to ask us or you want us to cover, feel free to post it on the chat. I guess one thing that's left to do is probably just introduce ourselves and say what we're hoping to get out of this, Don. So I guess I just wanted to give you a chance to, you've introduced yourself at the pilot episode, but I just wanted to remind everyone that you are the Mbed OS Tech lead. So, just maybe give a really short intro, and then people could go watch the episode, the pilot episode, to get more details.
Yeah, thanks, Alessandro. As you said, I've been the Mbed OS Tech lead for 6 months now. And what I'm looking forward to in those tech forums is basically discussing a little bit more closely with the community, so getting more feedback and also sharing what we've been up to. As you said, today, for instance, we're going to be talking about build systems and CMake. We're going to be talking about ML. And I think, and that, as you said, that's probably what's the most exciting bit. We're going to be talking about rockets. So yeah, we're really looking forward to this lineup. I hope we'll be able to fit everything in. We've also had quite a few questions on the forums already, so we'll try and do our best to answer those. So yeah, feel free to use the chat and during the show, and we'll try and do our best to answer those as well.
Yeah, no, that's great. And actually, as you said, I think it's so cool that we already got so many suggestions and questions from our developers actually out there. So we'll try to address that at some point during the stream. We'll probably address some of them throughout the stream. But I think now it's probably, we should start this with a bang. So we should really start with rockets right away, right? So I think we should bring on our guests, Jamie and Jay. Hello, guys. Jamie and Jay are from the avionics team at the USC Rocket Propulsion Lab. It's really great to have you guys on the show today.
It's cool to be here.
Yeah, it's great to be here.
So I think we talked offline, and I know a lot about you guys and what you're doing, but I'd like for everyone watching the stream to actually get a feeling for all the great stuff that you've started working, or you've recently worked on. I think before doing that, though, I wanted to kind of give you a chance to introduce yourselves and tell a bit of your background story of what you've been doing and how you got to this point, how you got to building rockets. I think it's probably one of those things that like everybody wants to do when they're kids, right? But you guys are actually doing it.
It's been a really amazing opportunity. I've personally been in Rocket Propulsion Lab for about 3.5 years, ever since I was a freshman in college. It's one of the most prominent engineering organizations at our school, in my experience, and it's really been amazing to be a part of it. RPL has been around since about 2007, and we've been working up towards making larger and larger rockets ever since our first few launches. We started with kind of more almost standard model rocket grade launches, and it took over a period of years. We sort of developed our technologies for building different things that were required for much more high performance vehicles. So first we learned about making fiberglass composite fuselages, fins. Then we moved to making carbon epoxy composite fuselages. Then more recently, we've been making our own like composite nozzles, and of course the part that I'm a big part of, which is making our own avionics unit. Until about 5-6 years ago, RPL used to use just off-the-shelf avionics components, but we had a lot of trouble with them not having the features we needed, with them breaking. So we started making our own homegrown avionics unit, and for that avionics unit, we chose Mbed OS.
So are you saying that you've sent Mbed OS to space, Jamie?
Yes, as a matter of fact, we did. If you look up our Traveler 4 launch, which was in spring 2019, which was the first undergraduate rocket to pass the Kármán line, and which is the boundary of the edge of space, that did in fact fly Mbed OS as our operating system for our avionics unit.
That's really awesome, and I think it would be great to hear from you, Jay, as well. But what I'm really looking forward to hearing a little bit more about how you ended up developing this avionics unit in practice, and the challenges you've had. I'm sure it's like extremely challenging, because I guess like if you get it wrong, then you lose the rocket or worse. So there's probably not much room for mistakes.
Right, for sure. Just as an introduction, I am a third-year member of the USC Rocket Lab. Like Jamie said, it's really a tremendous opportunity for the students at USC. One thing we pride ourselves in, like Jamie said, was that we really make everything ourselves, and that's really part of our spirit. To kind of give a little backstory on how Mbed became the kind of core part of our avionics unit, back in 2013, one of the original designers of the avionics unit chose Mbed OS for a very similar reason to what Don had mentioned in the pilot episode, that it was so easy to get started, that you didn't need one of those like really fancy JTAG programmers, that you could just drag and drop your binary file, use Mbed CLI, and just get off the ground quickly. But Mbed OS has really allowed us to scale from that kind of ecosystem to what we have now, which is that custom CMake build system, and a lot of newer features that have allowed us to better utilize our processor. And like you said, that there is definitely not a lot of room for error. We get one shot to launch this rocket, and if it does not work, we don't get to launch another one for a year, potentially more. And so this is definitely a huge undertaking, and we try to be very thorough in our testing and operations. So Mbed has been a huge part of enabling that kind of fault tolerant architecture.
It's really awesome to hear that you guys have been working on this. It's a passion project, right? Because it's not. I mean, you're not getting paid to do this, but you're developing rockets that are going into space, and I think to me it's just amazing, right? To hear that that's possible, and you guys are doing it kind of on the side, right? But you're still managing to do all the proper checks and get everything right? Because as we said, it's also probably really expensive if you get it wrong, right? So it's super interesting, and I'd love to hear more about this story. I know that you guys have got something to show later on, but I just wanted to bring up that some of our audience, iShot JR, is super excited as well about the rockets. So I'm looking forward to more of this. Actually, that said, I think it's probably time to actually show some of the stuff that you've been working on. Jamie, you had something to show, right?
Let's see. If for anyone who's interested in seeing, we're using my house as our temporary dev location. So this is actually the avionics unit that's going to be flying on our next rocket launch, called Dome Piercer. So it's composed of 3 donut PCBs that stack together with each other, and all of these. So the top one handles like connecting to other components, big vibration tolerant battery connector, and has some of our RF components. The middle one's voltage regulators, and the bottom one, which you can't actually really see very well, is all of our sensors and processors, including an LPC 1768 running Mbed. Yeah, I know it's an old processor. We're definitely looking to upgrade, but it's served us well for many years. And I can also show what our avionics software looks like. If anyone's wondering, this is actually the operator console that we have from a. This is actually the operator console. What it would look like if you were sitting in our operations trailer running our rocket, which was Jay's job at the Traveler 4 launch. So it does indeed have a command line interface. We use a radio called the XDEN, which is an XB type that basically just sends characters back and forth. It's simple, but it's also very easy to do, and it works well. We have our nice really startup diagnostic, all sorts of sensors on here. And we also have our own custom flash log system. That's like a fault-tolerant file system for recording data to a flash chip, and with like checksums, and it records sequentially, so it can't possibly overwrite. Shows all of this and all of our sensor data.
That is really impressive. I think like a question that springs to mind is so you mentioned that robustness is like a key thing, and I guess we're all, as engineers, we're all dreaming about continuous integration, and I guess for you, I guess that means that you can't launch have your nightly CI, launch a rocket overnight, and give you the result the next day. So how do you approach testing? How do you approach those challenges so that on launch day you're fairly confident that things are going to go right?
Well, we have a number of different checkouts. So I'd say we do both sort of software only tests and software and hardware tests, and we're definitely looking to even expand our testing abilities even more, because a couple years ago, we didn't have a whole lot of testing capability like when we started. So that's definitely been something we've been trying to build out in the last couple of years. On launch day, we have a ton of checkouts that we do. Now, most team members, if we're launching at like 7:30, most team members have the luxury of waking up at like maybe 6. Not avionics team. We got to wake up at 3:30 to start launch checkouts. And so we have like a whole checklist, testing every sensor, testing the flash log, making sure everything's producing correct data. We also build all of our own PCBs ourselves. So that's an awesome experience, but it also means that we have to do a little more checking because there can be some reliability errors. I can say this as someone who almost caused a serious fault in a flight PCB, that it can happen. So we have to be very vigilant against that kind of thing. And we've also been working on building out our software things, like Jay's automated testing, or ATS.
Yeah. So, testing embedded software has, it's always a challenge, right? How do you test software that's meant to run on custom hardware in a CI environment, or in a way that you can easily get bugs identified and fixed. And so from our perspective, like Jamie said, 2 years ago, we didn't really have that capability. And as we go on, we're getting more and more robust systems. So in a way, a kind of fake operator to send serial data to and receive from the unit, parse it, identify its state, and continue, right? So something like that. We're working on hardware out of the loop simulation. So part of that is kind of a emulation layer for Mbed's RTOS on the PC. And so we can test multi-threaded code within a desktop environment without relying on the commodity hardware. And Jamie has been a big part of that development effort. As well as hardware in the loop testing. So how can we inject sensor data and retrieve the actuator outputs from the unit and pipe that into our in-house simulation software that does aerodynamic modeling and stuff like that. So kind of building out that entire pipeline of mocking out various levels of interface has really been our focus right now for testing.
Excellent. I think that testing these kind of complex systems, and I guess you have to integrate like tooling, which is very different. Like you have, I guess, some physics simulation software that you have to integrate to your embedded simulation software. I guess it must be fairly different things, right? That you have to make work together.
Yeah.
So something you've touched on is that you are now making your own PCBs. So it's like a lot. I guess you're owning a large part of the stack. How have you found the experience of bringing your software from, I guess, what used to be developer world to your custom hardware with your custom sensors and the specificities of your hardware. How's this process gone for you, and has it been challenging, or have you managed to do things that have helped along the way?
Well, I'm happy to say that we didn't have a whole lot of issues switching to our own custom hardware. It kind of happened gradually. Like we used we actually did in one rocket fly an Mbed dev board attached to like a bunch of soldered breadboards with components on them. Then we moved to the Mbed dev board socketed into a custom PCB, and now we're onto a completely just integrating the stuff from the dev board onto our PCBs. So thankfully, we were able to find the schematics that we needed, and it wasn't too difficult to figure out how to do that once we were able to find all that information. We did have to do a little bit of, it took a little bit of stuff, but it wasn't that bad.
Did that work, Jamie? Do you remember if the breadboard had won? Was that Deja Vu or what?
That was Tire Biter. I don't know if it worked. I think it worked. The rocket exploded, so we didn't really find out too well.
Yeah, that's one of the risks. Like we spend quite a lot of time building the avionics unit, but we might never get it back. The rocket might just blow up.
Well, that one didn't exactly blow up. It just disintegrated after about. No, actually, it ended up not. It had aerodynamic problems. I'll put it that way.
So I guess that's why like the telemetry link is quite important, because you want to extract as much data as possible without having to recover the rocket, I guess.
Yeah,
for sure.
Another thing that we've had to do is a lot of build system type stuff. Because when we started, we had some requirements for the build system that were a bit different than we could get with Mbed CLI. One of them was we needed like offline operation, because we had to be like out in Black Rock, Nevada, where there's no internet. So we had to make sure we could still change code and build while we were out there. Another issue was that so we used to use like Mbed web interface, so that wouldn't have really flown for there. So we did use export and make files for a while. That was good when we had it, but we had some problems with version controlling. So that's kind of when we decided to start moving to CMake, because it made it a lot easier to share the project among a lot of people.
So can you tell us a little bit more about Mbed CMake and how that project came about, and yeah, like so you've mentioned a few problems you had to, or challenges you had to solve or overcome. How did that project come about, and how did that help you overcome those challenges?
Yeah, so as I was saying, we basically needed a build system with a little more capability. So besides offline operation, another thing that we needed was the ability to have multiple targets in a single build system. So because we had like little test programs that would test each sensor, very useful in building the PCB. But they shared most of the same code with our avionics unit, so it was nice to not have to make a different project for each one of those. Another common thing was the ability to have extra configuration options in the build, like basically having some kind of config option we could use, say, hey, use the flight radio, or hey, send STD out to the USB port. One of those two, like decide what to do with that. Those were very useful. And it was also nice, like version control, like better version controllability and collaboration were probably the main reasons that we needed it. Oh, and also IDE support, because I'm a big CLI fan, and I think a lot of other people are here. Sorry to choose favorites, but the nice thing about using CMake is it solves these kind of IDE wars, because pretty much anyone can use the build system they want to, and you don't have to worry too much about like, oh, but it doesn't work with this IDE, or it's only specific to this build system. Nope, it works with all IDEs and build systems. So we originally wrote one that basically just kind of replicated the makefile build system with like just basically hard coding the flags. But earlier in the year, while I had some time free, I converted it to being a bit more general so that it could work for any Mbed target. And what that meant was writing a scraper script that interfaced with Mbed CLI and output all of the source files, flags, etc. to a file. So then CMake could load that file and build all of the code. And that's been working for us pretty well for the last 6 months or so.
That's really awesome, guys. I think it's a good time to play a video that you guys have shared with us, which shows like a little bit more about what RPL does, and then we'll bring in Martin, who has been working on CMake within Mbed OS as well. So it'll be great to get to continue this discussion with him as well.
Yeah, let's play the video.
In the Rocket Propulsion Lab, we design, simulate, and manufacture all of our parts in-house.
To even have the opportunity to do this now, when this was something that I made like a career goal for myself, it's crazy. Like, I was a part of that.
I joined the Rocket Lab basically day one of freshman year, actually before even classes started. Why would I do anything but this? This is so cool.
Ready?
This is huge. This is super cool. I mean, we've had a message from iShotGR in the audience saying that he didn't realize the scale of this. And I think I actually, you know, when I first saw this, I also thought the same, right? I was like, I thought you guys were talking about like small rockets, but these are huge, right? It's really cool to see. And I think some of the comments from the people, you know, part of the whole Rocket Lab were just really cool. You know, someone said, why would you do anything else, right? That made me really smile, because I was like, yeah, I'd probably think the same if I was involved in rockets. So that's super cool to see that. There's a couple of questions actually from the audience that I wanted to take before moving on to talking more about CMake. So let's take that. So we've got one from iShotGR saying, talking about the recovery method for this class of rocket. So what are you guys using? Parachutes, VTOL?
We still use parachutes. And I will say, in our quest to get to space, the safe recovery of our rocket is something that has kind of been sacrificed slightly. As in, we don't have enough space for a very large parachute in the bay when you include all the propellant, so it hits the ground at several tens of miles per hour. We launch out in the middle of nowhere, though. And I think on Traveler 4, actually several of the fins broke off when it hit the ground. But the avionics unit survives. That's what I care about. We have definitely had rockets that even lost part of their parachute. Those ones had close to a 100 G impact when they hit the ground.
Well, so you're really testing your soldering skills there, Jamie. Right?
Yeah, we put special potting compound on the boards to make it more likely the components will stick on properly. It's tough.
Avionics is probably the most sensitive kind of equipment that's on the unit. So the structures around it that hold the unit to the case or the nose cone and prevent it from getting damaged is really critical to our operation, I guess.
Yeah, there's more people saying that you're lucky working on this.
We definitely are. Definitely are.
And one last question, actually, from Win. He just asked it. So would be nice to know, what are the development tools you use with Mbed and why did you choose them?
Well, I mean, we use CLI as our IDE, and we really work on any operating system that anyone comes with. So I don't know. The development tool we wish we had was in one of those JTrace things for doing profiling. That'd be cool, but we don't quite have the spare budget for one these days.
Yeah. I guess, compiler side, we use GCC, ARM GCC. It's available. So I guess that's why we're using it. Yeah, I guess that we don't have a ton of open source like software running on the stack other than Mbed OS. I think.
Oh, we have some of our drivers that we've made open source.
That's true. We have made this open source.
Yeah, we're trying to open source a number of our different drivers. You might have seen our thread on the forums. Like I did the B080 driver, which was that sensor can be a bit of a pain to work with. So I'm hoping that I can prevent anyone else from having to work with it like this. We've also done things like the we've open sourced some of our testing thing with Mbed Bench Test. Open sourced ATIS1647. I forget the model number. A couple of other different sensor drivers that we use, and we're working on open sourcing a few more even.
That's really cool, and I think it's great to see how much help you're helping the community, right? I think it's super cool. We mentioned earlier CMake, and I think this is probably the time to actually bring on Martin and talk more about the work that we're doing. So Don, I'll let you introduce Martin, and I'll bring him in.
Drum roll, please. He's the lead maintainer for Mbed OS. His name is Martin Koital. Welcome, Martin. Thanks for joining us from Germany.
Yep.
Hey, Martin.
Hello, everyone.
So you're the main gatekeeper, right, for all pull requests. You're probably one of the persons that the community will talk to most, right?
Yeah, that's correct. Sometimes the people joke that I'm the face of Mbed, but only on GitHub.
It's great to have you here.
So I think you guys have met before. Martin, I know that apart from your day job, you have a second day job. You've had a second day job, which was delivering the next generation build system for Mbed OS based on CMake. And I think that when you realized that Jay and Jamie and their team had been working on Mbed CMake, you guys started talking. And I guess what have you learned from Jay and Jamie and their team when developing that build system?
So back then we were quite early in the stage. So I remember building some, I think, Blinky and everything included. So when we learned or found it on forums, we were like, wow, they're doing something similar. So of course we explored. We wanted to see how they use CMake, how they interact with our current build system, which we are still using. And then we just get in touch and discuss what we are doing. That back then it was still in private, it's really early, like draft only. Now it's public, so it's available, and we still keep in talking. Jamie sent a pull requests that we're really glad we have. Hopefully we will integrate them soon. And anyone can contribute. So I'll talk more about the CMake in my slides, talk about what we have currently, what we are working on. I think that's it.
Yeah, I will say when I started talking to Martin, it was interesting to know that actually the nice thing about our two systems that the interface from the your guys users' apps is actually very similar. So if you're currently using Mbed CMake, it should be very easy to switch over. It's basically just changing which build system you call and then changing how you add executables.
Yeah, that's one of the goals as well. Good point.
And also breaking it up into modules is really awesome. That's something I did not have the guts to do, but it means it's going to be really nice because it means no more messing around with embed ignore files. You can basically say, I don't want the connectivity library. I'm not going to link it. It's going to save space. It's going to save build time. It's going to be very convenient.
So you'll be able to bring a smaller solar panel to the desert to power your workstation, right? Hopefully. Alessandro, I think Martin, you have a small presentation that explains a little bit what you've been working on with the CMake team. Shall we let you describe that and tell us more about CMake the new CMake build system in Mbed?
Okay, yeah, thank you. So I'll start. So next slide. So I'll be talking about the CMake and the work we've been doing, I think, since starting the beginning of this year. So it's all started with Mbed tools. That's the currently called Mbed CLI tool. So the current build system, I can refer to it as the old build system now, this slide, are using the Mbed CLI 1. And we've been developing Mbed tools that will be the next generation. So Mbed CLI 2. That's all the part of the CMake work. So the CMake, we are still developing it. So it's still in development. It's more like ready for review or like a preview release. It's part of the Mbed OS 6.50 that was released last month. Therefore, as I mentioned, it's as an early stage. The contributions are really welcome, as Jamie sent in as well, and there have been already discussion on the forums, on GitHub, already a few contributions also from our partners, which are really appreciated, and it's really nice to see people are using it, and we're still can change things. So this early feedback is really great if we can get and can improve how we can make this build system work for everyone and learn from our experience, from our what we call the technical debt we have in the old tools. So hopefully we can fix a lot of things. The Mbed CLI tool, it uses by default Ninja as a build system and CMake to generate the build environment and manage the build in the compiler independent manner. We ported the Mbed config, so it's still without changes, so no breaking changes should be done, and you can use your JSON app, JSON, or Mbed libjson files, and just generate CMake, and then you can switch. You can use the Mbed CLI 2, or those who prefer CMake. Once the CMake build system is generated, you can switch to CMake and just run CMake, and it will build for you. Okay, next slide, please. So what's the current state of what we are doing? As I said, still working on it. So right now, we are using the latest CMake that was released, I think, only a month ago, because we bug fixed a few things there that we are using, like ARM Clang or GCC ARM. We found a few bugs. That's why I recommend using the latest CMake and also the latest Mbed tools. I think the latest is now 4.00. That was also released recently. We support both tool chains, as Mbed OS currently does, the ARM Clang and GCC ARM. The targets, we are still porting the rest of the targets, but as I just highlighted a few, it's STM32, Cypress, Maxim, Freescale, and there are probably 5 more already as a pull request that will be integrated soon. Also, besides the targets, we are also working on adding more features. I've seen already enhancement report on Mbed tools today about testing. So that's what we are currently working on and looking at how to support green tea, what we call our test runner and our test framework for Mbed OS. So we will port it to be supported with CMake and a C-test, and that will be added to Mbed tools as well. Other worth mentioning, it's TFM and some other additional features that old tools have. and are currently not supported in CMake, for example, the post-binary hook, and many more. So what was the biggest change, as Jamie already mentioned, it's this modularity with CMake. So we introduced CMake libraries. The main goal with introducing this was to reduce the build time and also to decrease the Mbed OS footprint. Because as you might know, the current tools, they include everything, and you use embed ignore file to ignore what you don't want. So by default, everything is included. So you kind of let linker to decide what should be there, but linkers are not sometimes with global symbols and things around it, what we use in embedded are not that clever. So still what you don't use, it might get into your image, the final image, and also the building time, because everything builds. So the rebuild takes on my machine sometimes like 10 minutes on my laptop, which was really time consuming. And that's why we decided we need to do something about it. What the CMake provides, there are two main libraries to interact with. So it's Mbed OS and Mbed bare metal, which if I touch a bit of implementation detail, it's Mbed OS is basically Mbed core with a target and how and platform and drivers. And the bare metal, it's the core and without the RTOS, so this target platform drivers, but no RTOS included. And everything else within Mbed OS is a library. So we provide Mbed sockets, Mbed BLE, cellular, and all the rest. So the application can decide or what it needs. So there is also with these target link libraries, what CMake provides that you can just create dependency list, so you can link other dependencies. So for example, if you're using, let's say, Mbed storage KV Store has dependencies on other things like TLS, because it provides some wrapper on top of its storage, like QSIF, for example. So all these, it's really nice to have there. And by default, application needs to request. So if I'm writing a storage driver, I request Mbed storage. If I'm writing, for example, BLE, or I want to add BLE sensor, I just add Mbed BLE to my application. There is also code snippet that shows Blinky that all you need is just Mbed OS. And if I want any other libraries, I will add a new line there and would add what I already mentioned. Next slide, please. So how we achieve this reduced build time? So this is what I'm going to show you in real numbers. So I took two examples, the Blinky and KV Store. I run the Mbed Tools compile command for Disco board, the IoT platform, for GCC. So the first node, the most important node, it's with all tools. The building Mbed OS takes a couple of minutes depending on the machine, and because everything is included, it's I think over 1,000 files. It's somewhere like 1,200, as I remember from the top of my head. It used to be. How is it now with these libraries? Mbed OS example Blinky with Mbed OS for this target, it's 260 files. If you switch to Mbed bare metal, which is like minus RTOS, so it's for around 23 files less. For the KV Store, because you're including additional storage and additional like Mbed TLS as a dependency and others, then you can find out if you look at the storage component or library, there are 382 files. The number of files depend mainly not only on the component, but mainly on the target code as well, because targets include the third-party drivers, like the SDKs. So some targets might be ported only without the SDK, so you can get, I don't remember the target from top of my head, but there is one, you can get like 160 files with bare metal only for Blinky, of course. And because of this, we include only what is needed. Also, the footprint is lower, so someone from the community already shared some numbers when they were comparing the old tools with the CMake. There was one 10K flash less for Blinky, and I think RAM also was reduced. Next slide. So how to achieve the speed? This is the comparison between KV Store and the Blink example. The CMake file is CMake list in the application root. It's the same. The only difference there is in these link libraries. As you can see on the left, there is a Blinky, which does not need anything else, just Mbed OS. On the right side, there is KV Store. And I just, because I'm using the KV Store, I just request new additional library on top of, or along with Mbed OS, and that's it. Nothing else. Everything else is now done by CMake, and within Mbed OS, as I mentioned, the dependencies, everything is resolved. And that's all what differs between these two, if you look at the CMake. Next slide, please. So I believe this is my last slide. So I'll mention in one of the first slides is that we are still developing it. Therefore, the early feedback is really greatly appreciated, and we are glad to review issues or pull requests and just work with the community and all of you to improve what we have currently and just get it better, make it better day by day. So how can you contribute? You can create the issue on our GitHub issue tracker. That's Mbed OS issues. That's the first one. The second one is Mbed tools. I talked about somebody already requested as an enhancement test comment. So if you find like our tools currently, Mbed tools do not provide something that the old build system provided, just create an issue and we will get back to you and see what we can do and when we can plan the next, what's missing there. And also for discussion, just use Mbed OS Forum. I think that's it from me. Thank you very much for having this time to talk about CMake.
Thanks so much, Martin. That's really good to see to hear about what you've been doing, and so I guess like the between all of those communication channels, people can reach you pretty easily, and to help you improve the build system.
Yeah, and we'll link. So there's a couple of channels, that you showed there. So we'll link all those channels on the description below the episode, so you can access those later. Martin, that was awesome. Thank you so much for sharing all that. I think we should probably get moving on the next section. But before doing that, I'd say we say goodbye to all our guests. I'm keen to have you guys all back on at the end for a goodbye and maybe some Q&A, some last Q&As. But for now, I'd say it was great to have you guys, and we'll see you back in a few minutes. And Jamie, I think you're going to have to leave, so it was great to have you on the show. Thank you so much.
It was great being here.
So we'll stay with Martin in case there's anything we need to cover, because I think I'm keen to, Don, I don't know what you think. I'm keen to kind of take a look at the live stream suggestions that we got on the forum, actually. So I'll bring that up and we can perhaps address some of those questions and ideas. So here we go. So this is, these are the issues or the suggestions that we got. And I think we don't have a lot of time. So I'm wondering, should we maybe focus on a couple of the points here, and then we can answer the rest of the points offline and on the next live stream as well. So, if I ask you, what should we cover?
So I think let's take the question of OTA or FOTA. So I think it's something we've been asked a few times already. So that would be great to give an answer. I think it will apply to a lot of folks. So FOTA, where are we with it? So first, we think it's something which is definitely in scope for Mbed OS. Like, we want to build a solution that simplifies IoT projects, and firmware updates are a key component of that. So we can't say when exactly will be able to deliver something along that. But I can give you a little bit of background in terms of what we're doing today to look at FOTA. So for instance, we've started looking at MCU boot as a potential bootloader for that we could use in Mbed OS to actually provide the firmware update functionality. There's also something happening elsewhere in the platform security architecture group, which delivers security specifications. And these guys have been working on a specification for a firmware update API. So we would like to adopt that specification. And the challenges with this specification is that it has to be cloud neutral, so it has to be usable with the various cloud service providers. So that's something we want to talk to those guys about to make sure that we can have a solution that works for them in Mbed OS. And it also needs to address their security requirements. So that's something else we need to make sure they're happy with. So at this stage, we're, I think, quite in the early stages. We're starting to define to list, the problems from Mbed contributors we've seen, problems from folks who are using Mbed, who are giving us this feedback, but also the cloud service providers and the feedback from the PSA folks as well. So I think it's a really good time to hear more from the community on FOTA in general and get some examples of use cases where FOTA is needed and how folks are implementing it today, so that we can then build the best solution based on that.
Cool. So let's just I guess give a quick answer on the second one as well here. That I think came up a couple of times actually on the forum. So the question is around roadmap. Can we, are we going to share a public roadmap? Don, I'll let you answer that
So yeah, roadmap. I guess the answer is yes. Public roadmap, yes. So this is a pretty consistent feedback we've had, and I think as has been highlighted, not having that public roadmap here sometimes is not helpful for the community. So we want to address it, and I think we're aiming at publishing something in January. So that would be the first. I think we would publish initially what we would want to do in the first quarter of 2021.
Yeah, and I wanted to say actually on top of what you just said, that actually the whole reason of the stream is also to kind of share what we're building and what we're working on, right? So CMake, now we'll talk about tinyML in a few seconds. So really, it's I think part of this is actually sharing the roadmap effectively. But Don, as you said, we'll have a more formal roadmap soon. So that's cool. And I think, there was a few other questions that were really interesting. I mean, another one about target audience. Do you want to take that, or should we take that offline? I mean, up to you.
I think I can try and answer it briefly. I think it's a really good question. I think, ultimately we want professionals to be able to adopt Mbed OS, right? We want folks who are putting Mbed OS in rockets to be able to do that with confidence. So we want to be able to develop a professional solution. That being said, we don't want, some of the strengths that Mbed has, which are around, getting to something quickly. We don't want to give that up either. So a lot of work we're doing today and we're planning on doing is around quality and testing. So we want to continue that work, and moving forward, we will also want to, I guess, if firmware update is a good example, we'll want to build high-level frameworks that let you build solutions, like end-to-end solutions, quickly. And I think that question asked us about the competition. I think, well, I guess the Mbed OS positioning is that we ideally we want to provide something which is different and complements these other operating systems instead of we don't want to be competing, head to head against them. I think they all have their specific. We all have like some areas we're addressing, so we want to make sure we're complementary. And I guess the Mbed OS positioning is we want target IoT projects, and we are cloud neutral, so we want Mbed OS to work with any cloud.
Cool. Thank you for addressing that. And I guess before we move to the last bit, to the future, I wanted to actually take one question from the audience. So Louise asked a question to, I believe this is for Martin. So he's really happy about CMake and what you guys are building. He's asking when the final version will be available. I don't know if you've got any timeline on that.
Yeah, we don't have yet. We still kind of porting the targets, and we are learning what's broken. Like those bringing the libraries took us more time than we expected because there are dependencies, and we had to clean also a few things. So with the targets as well, and there are some features that we probably haven't yet planned from the old tools. So we also will hear the feedback from the community, like what's important to bring back or port from old tools, what we should kind of discourage not to use anymore. So we don't have any specific timeline. We will iterate and make it better.
Martin, it's fair to say that the bar is more in terms of like quality and scope rather than the time frame itself.
Yeah.
Cool. Okay, so I think we're left with the most exciting part, actually, the future of what we're building, right? So, Don, you want to spend a few words, or should we actually let's bring Carlo in. We've got another special guest. Maybe we can show what we can do today with machine learning on Mbed, and then we can talk about the future. So, let's bring Carlo in. Hello, Carlo.
Hey, Carlo.
Hello, everybody. Thank you.
Hello, welcome. Yeah, so I guess, really we wanted to talk about machine learning, as we believe this is a growing need for our developers, right? So we really want to understand how we can better help developers wanting to do machine learning on tiny devices today, right? But, there is a lot that can be done already. So, Carlo, I wanted to kind of give you a chance to walk us through some of the work that you've been doing today on Mbed. So, take it away.
Yeah, thank you, Alessandro. So the first thing that I wanted to talk about is just to because I really want to drive this point home, is that many people don't realize that you can actually run some pretty interesting embedded machine learning applications on Mbed. Usually, I've seen some projects of people doing some fancy image processing, so image applications. There's been some voice applications, some anomaly detections. And the way that all of this is possible is because of a library called TensorFlow Lite Micro. So many of you will probably be familiar with TensorFlow, which is one of the most popular machine learning libraries for high-level programming with Python, developed by Google. And they've developed a smaller version of this library that you can use in conjunction with Mbed OS, which essentially what you do is you take a data set, in our case for a voice application, let's say, you take the Google Speech dataset, which has over 30,000 words. And then what you do is you take the speech command, run that through a fast Fourier transform, apply convolutional neural network on that spectrogram, train the neural network, and then we could boil that model into an array that you can put on a microcontroller. And then I'm going to show you a guide that we've been working on for how you can do this yourself on a Cortex M4 device, in this case, the K66F from NXP. And so this is the guide we have.
I'm sharing the guide. I'm sharing the guide as well.
I was sharing the screen. Okay. Yeah, so this is the guide, and it's really simple. Is it okay if I share the screen? Because I just want to hit a few points.
Oh, yeah.
Can you see my screen now?
Yep.
Yeah, so it's really simple. If you have a K66F laying around, they're pretty cheap anyways, you can just pull down the TensorFlow repository, you cd into the Mbed folder, And if you want to run it with the latest version of Mbed OS, you just have to change 2 lines of code to support the latest version of Mbed OS. You compile, and you run a few commands to initialize the Mbed project. You deploy to pull in the latest libraries. You compile, and then you can hear the project. If you say yes, it'll recognize that word by the process that I described before. And so it's pretty exciting, that you can do this on a Cortex-M4 device. And I think many people will start trying out new possibilities to see what we can do with embedded machine learning.
And in the interest
that's really awesome, Carlo.
Yeah.
Sorry, go ahead.
No, sorry. I just wanted to say that we've actually got we were planning to do a live video, a live demo, but actually in the interest of time, we've got a recorded version. So I wanted to play that, and then we can discuss for this further. But I'll just play that video.
So the final step is to just plug in our board. The green LED should start blinking, and then we just need to speak our keywords into the microphones, which are near the Ethernet port right here on the board. So just plug it in. No. No. Yes. No. And there you have it. Now we can do keyword spotting on a NXP K66F.
And there you have it.
That's really awesome, Carlo. Maybe can I ask you, what do you think would make this, what would have made your life easier when building that demo?
That's a really good question. So the first thing, I guess, would be this particular demo from TensorFlow was running on an older version of Mbed OS, and we had to change a few things on the debug log file to actually get it to run with the latest version of Mbed OS. So I think easier transition to porting from one version of Mbed OS to another, especially where APIs are deprecated, I think that would have made the transition easier. But specifically for embedded ML applications, just ways of tracking your model size, right? Because you need to make sure that you're abiding by the memory constraints and that kind of thing. Those kinds of tools would be helpful.
That makes sense. And I guess maybe something else we should probably say is that I think you're using the K66F's HAL directly. And maybe something that actually would help with this type of applications is a more standardized audio framework in Mbed, or
certainly,
like
yes, that is very true. I also tried this same demo with another board for which I didn't have the audio drivers to get for example, the L475VG. There's the audio driver is not at the moment supported by Mbed OS, so that would have been quite a pain to port that, because then you have to do the audio work and then the audio processing, digital signal processing on that front as well before you feed it into the model. So yeah, that would also be very helpful.
Makes sense.
And I mean, it's as we said, it's cool that this stuff can be done already. But Don, you were kind of hinting to the fact that there's a lot of work that we could still do to enable even better user experience, developer experience, but also add more features and add more capabilities to Mbed OS, right? So I'll let you kind of lead, but I think I'm keen to have as much feedback from the community as possible on this.
I'll keep it short, but I guess the things that there are so many things we need to look at around him. So getting the feedback from the community there is really important, because we need to know where there's the most value, right? But how do we integrate different ML libraries in Mbed? So you have this TensorFlow micro. There's also other libraries which are getting momentum, such as micro TVM. So that's one. There's usually a lot of ML-oriented platforms that have dual core architectures. So how do we handle dual core? The audio and imaging frameworks are also something else. I could go on like how do we extract training data in an easy way? That there's so many challenges. So I think we're sort of running out of time, but it would be maybe what we can do is create a forum thread and start engaging on those topics.
Sounds like a good plan. And I wanted to actually address one last point before we close. There was actually so we posted Carlo's demo on YouTube, but there was actually a comment. Someone caught an error, and we fixed that. So now if you go, and I'm not sure if so thank you, Hubert, I think it was, Hubert, for raising that. And if you look at the doc now, it's fixed, so you can try it again. Just wanted to mention that.
A memory leak, right?
Yes, there was a memory leak that we hadn't spotted. So yeah, thank you for that. It was a really simple thing, by the way. But yeah, cool. So I think we've covered everything we said we were going to cover. Don, was there anything else that you thought we should have covered that we didn't cover, or should we bring in back Jay and maybe just?
I think we should bring back everyone. That would be great. That's our first live stream, so I think any feedback is appreciated. There's a forum thread, so feel free to tell us what worked, what didn't work, what you'd like to see in future live streams. That'll be really helpful for us to make them more useful, or even more useful. Yeah.
And there's a bunch of comments, Jay. You probably saw them from people watching the stream. So Lauren, I think actually she might be part of the team.
Yes, she is. She is the current lab lead, actually.
Awesome.
Like she said, putting ML on a rocket has been kind of a pipe dream for us for a while. It's not something that gets done very often, and on the amateur scale, it's a really great kind of platform for experimentation, because there's not so millions of dollars at risk. So yeah, I think the ML with Mbed OS integration is really, really cool, and I think we might hit you up on that.
Awesome.
I'm really looking forward to seeing that, to watching that launch.
Yeah. That'll be a few years down the line at least, but
this is a good way to, I guess, end the stream, right? Like, you guys are going to contribute to our future of ML and Mbed, right? So I think you just said that you've got a lot to say on this topic. So yeah, I'm looking forward to the contributions. I mean, in terms of on the forum at least, right? And then we can discuss it from there. But no, it was awesome. Thank you, Jay, and Jamie had to leave, but thank him as well when you see him. Thank you, Martin, Carlo, and Don for being my co-host. It was a pleasure. Thank you, everyone.
Yeah, likewise. Yeah, thanks again, Carlo, Jay, Martin, and Jamie. Yeah, it was really awesome having you guys on the show today.
And I wanted to thank everyone watching, actually. Well, running a show with you, right? So I wanted to, we're getting an applause from my shot JR. Thank you for watching. But I wanted to thank everyone for watching the stream. It's been a pleasure. And as Don said, we have a forum post where you can add suggestions and tell us if we need to do anything differently, or if you want any topics to be covered on next streams. Thank you so much, everyone, and look forward to next stream.
Thanks so much. See you in January.
Bye, everyone.
Bye.